Hello, I am Narciso. In this video, we will discuss the mean, the median, the mode, and other measures of central tendency. The measures of central tendency is also known as the average. So what is the average? The average is a value that is a representative of a set of data. In this video, the topics that we will cover here are arithmetic mean, median, mode, midrange, geometric mean, harmonic mean, quadratic mean, and fractiles. What is arithmetic mean? Or simply mean? The mean is the most popular among the measures of central tendency. The formula to compute the mean is x bar is equal to x sub 1 plus x sub 2 until x sub n, or the last element of the given dataset, divided by n, or the total number or elements in a given dataset, or simply it is the summation of x over n. So examples: find the mean of a dataset 3, 4, 9, 10, and 14. So to get the mean, so we will just add the given numbers 3 plus 4 plus 9 plus 10 and plus 14, divided by 5. So this is the total number of elements in the given dataset. The number of elements in the given dataset. So that is 40 over 5, or equals to 8. Another example: Anna's grades in 4 subjects are 89, 95, 86, and 87. What is her average grade? To compute Anna's average grade is, we just add all her 4 grades and divide it by 4. So therefore, Anna's average grade is 89.25. If the numbers x sub 1, x sub 2, x sub k occur f sub 1, f sub 2, f sub k times respectively, the mean is f sub 1 times x sub 1 plus f sub 2 times x sub 2 until x sub k times x sub k over f sub 1 plus f sub 2 until f sub k, or simply this is the summation of f times x over n. So example: find the average of 2, 7, 7, 4, 4, 4, 4, 5, 5, and 5. So to compute the mean or the average, all we have to do is just multiply 2 by 1. What do you mean by 1? So if you will see here from the given set, there is only 1 here. There is only 1, 2 here. So 1 times 2 plus 2 times 7. So there are 2 7s plus 4 times 4. So there are 4 4s and 3 times 5. So we have here 3 5s. So the average is 47 over 10, or 4.7. So let's proceed with the weighted arithmetic mean. Sometimes we associate with the numbers x sub 1, x sub 2 until x sub k something weights w sub 1, w sub 2 until w sub k, depending on the importance attached to the numbers. The formula of the weighted arithmetic mean is w sub 1 times x sub 1 plus w sub 2 times x sub 2 until w sub k times x sub k over w sub 1 plus w sub 2 until w sub k, or simply it is the summation of w times x over n. So example: the grade of a student in final exam is 87, in project is 95, and in quizzes are 70 and 84. What is the mean grade of a student if his project is weighted twice as much as his quiz, and his final exam weighted 3 times as much as his quiz? So to solve for the mean of the grade of a student, so x bar is equal to 2 times 95. What does it mean? So 95 is his grade in project, but based on the problem, the weight of the project is twice as much as his quiz, plus 3 times 87. So 87 is his grade in final exam, but the final exam weighted 3 times as much as his quiz, and plus 1 times 70, one of the grades in quizzes in quiz plus 1 times 84 divided by 2 plus 3 plus 1 plus 1. So this number are actually the weights of every grades. So 2 is the weights of 95 or the project, 3 is the weights of 87 or the final exam, 1 is the weight of each grades in quizzes. So the weighted arithmetic mean is 605 over 7 or 86.43. So now let's proceed to the median. The median is the halfway point in a data set. The data must be arranged in order, so take note with this one. So in order for us to compute the median, we have to arrange the data in order. The data set in order is called a data array. The median either will be a specific value in the data set or will fall between two values. So to find the position of the median in an ungrouped data, we have to use this formula. So the position of the median is equal to n plus 1 over 2, where n is the number of data or elements in a set. So example, the final grades of 7 students in statistics are 85, 94, 76, 86, 87, 96, and 80. What is the median? So first step, arrange the given in order, either ascending or descending. In this case, I arrange it in ascending order. So step 2, find the position of the median, where n is equal to 7. So there are 7 numbers here. So the position of the median is n plus 1 over 2 or 7 plus 1 over 2. So equals to 4. So that means from left, count the fourth element. So 1, 2, 3, 4. So that means 86 is the fourth element, and that is our median. Another example, the height in centimeters of 10 students are 135, 137, 140, 158, 167, 171, 172, 175, 183, and 188. Find the median. So if you will notice, the given is already in ascending order. That means the data is already in an array. So step 2, find the position of the median, where n is equal to 10. So the position of your median is 10 plus 1 over 2 or 5.5. It means that our median is in between the fifth element and the sixth element. So if we count from left to right, so 1, 2, 3, 4, 5, and 6. So that means our median is between 167 and 171. So therefore the median is, all you have to do, get the average of these two numbers. So 167 plus 171 divided by 2, or 169 centimeters. Let's proceed with the mode. So the mode is the value that occurs most often in the data set. The mode may not exist, and if it exists, it may not be unique. So a data set that has only one value that occurs most is unimodal. Bimodal is a data set that has two values that occur most. Multimodal is a data set that has more than two values that occurs most. So examples. Number 1. The set of number is 2, 3, 4, 4, 6, 7, 7, 7, 9, 9, and 12. So the mode is 7. Why? Because if you will notice, 7 appears 3 times, while 4 and 9 appears twice. So therefore our mode is 7. So this is what it is, unimodal. The set 1, 2, 3, 1, 3, 8, 10, and 15 has no mode. So example number 3. The set 3, 5, 5, 5, 8, 9, 9, 10, 10, 11, 11, 11, 15, and 18 has two modes, 5 and 11. So if you will notice, both 5 and 11 appears 3 times. Let's proceed with the midrange. So the midrange is a rough estimate of the middle. It is found by adding the lowest and highest values in the dataset and dividing it by 2. It is a very rough estimate of the average and can be affected by one extremely high or low values. So the formula to get the midrange is just add the lowest value and the highest value and divide it by 2. So examples, find the midrange of the data 3, 8, 9, 10, 4, and 5. So our lowest value is 3 and the highest value is 10. So 3 plus 10 over 2. So equals to 6.5 is our midrange. What is the midrange of the salary of the teachers? The salary are in 1,000 pesos. So 10, 12, 15, 17.5, 21, 22, 25, and 30. So the midrange is, the lowest value is 10 plus the highest value is 30 over 2. So 10 plus 30 over 2 is equal to 20. So what are the properties and the uses of the mean, median, mode, and range according to Blumen? So the mean is found by using all the values of the data. The mean varies less than the mean or mode when samples are taken from the same population and all three measures are computed for these samples. The mean is used in computing other statistics such as the variance. The mean for the dataset is unique and not necessarily one of the data values. The mean cannot be computed for the data in a frequency distribution that has an open-ended class. The mean is affected by extremely high or low values called outliers and may not be appropriate average to use in these situations. The median. The median is used to find the center or middle value of a dataset. The median is used when it is necessary to find out whether the data values fall in the upper half or lower half of the distribution. The median is used for an open-ended distribution. The median is affected less than the mean by extremely high or extremely low values. So the mode. The mode is used when the most typical case is desired. The most is the easiest average to compute. The mode can be used when the data are nominal or categorical, such as religious preference, gender, or political affiliation. The mode is not always unique. A dataset can have more than one mode, or the mode may not exist for a dataset. The midrange. The midrange is easy to compute. The midrange gives the midpoint. The midrange is affected by extremely high or low values in a dataset. So let's proceed with the geometric mean, the harmonic mean, and quadratic mean. So geometric mean is the nth root of the product of n values. It is useful in finding the average of percentages, ratios, indexes, or growth rates. So the formula for the geometric mean is the nth root of the product of x sub 1, x sub 2, x sub 3 until to the last digit of the given dataset, x sub n. Examples. Number 1. Find the geometric mean of the following. A. 1, 2, 3, and 4. B. 2, 4, and 8. So solutions. For letter A, so we will just compute the fourth root of the products of 1, 2, 3, and 4, which is fourth root of 24, or equals to 2.21. For letter B, so since there are three numbers here or three elements, so cube root of the product of 2, 4, and 8, or the cube root of 64, which is equal to 4. Example number 2. If a person receives a 20% raise for 1 year after 1 year of service and a 10% raise after the second year of service, what is the average percentage raise of per year? So solution. So we will use here the geometric mean. So since there are two percentages given, 20% and 10%, so we will just multiply this and find the square root. So 1.2 for the 20% and times 1.1 for the 10%. the square root of the product is equal to 1.1489. So that means the average percentage raise per year is 14.89%. So harmonic mean. The harmonic mean is defined as the number of values divided by the sum of the reciprocals of each value. It is also useful for finding the average speed. So the formula for the harmonic mean is equal to n over summation of 1 over x. So example, find the harmonic mean of the following. Letter A, 1, 4, 5, and 2. Letter B, 2, 4, and example, what is the quadratic mean of 3, 5, 6, and 10? So the quadratic mean is the square root of 3 squared plus 5 squared plus 6 squared plus 10 squared over 4. So square root of 42.5 or 6.52. So let's proceed to fractiles. So the fractiles are values that separate the data set into equal groups. The quartiles separate the data into 4 equal parts and is denoted by Q sub 1 for the first quartile, Q sub 2 for the second quartile, and Q sub 3 for the third quartile. The decile separates the data into 10 equal parts and is denoted by D sub 1, D sub 2 until D sub 9. The percentile separates the data into 100 equal parts and is denoted by P sub 1, P sub 2 until P sub 99. So the formula in finding the position of the fractile in an ungrouped data is, the position of the quartile is m over 4. So n plus 1 to find the term where m is the unknown value and n is the number of elements in the set. So for the position of the decile, so just change, instead of m over 4 is m over 10. Same with the percentile, so m over 100. So example, given the data set 2, 3, 4, 4, 7, 8, 10, 12, and 15, find the first quartile, the 6th decile, and the 84th percentile. The solution. So let's solve first with the first quartile. So the position of Q sub 1 or first quartile is 1 over 4. 1 because we are solving for the first quartile. 4 because quartile is divided the data into 4 equal parts. So 9 because there are 9 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 elements in the given data set. So which is equals to 2.5. So it means that the first quartile can be found between the second and the third number. So therefore the first quartile is, so as you can see, it's between, what's our second and third number? 3 and 4. Okay, 3 and 4. So the second element, the integer represents, that is the second element. So our second element is 3. So 0.5 is the difference between the third and the second element. 4 minus 3. So 4 minus 3 times 0.5 is 0.1 times 0.5 is 0.5 plus 3, so 3.5. So this is our first quartile. So let's solve for the D sub 6 or the 6th decile. So let's find first the position of your D sub 6. D sub 6 is equal to 6 over 10 times 9 plus 1. Why 6 over 10? Because we are looking for the 6th decile. And why 10? Because decile divided the data into 10 equal parts. So 6 over 10 times 9 plus 1 equals 6. So that means the sixth element is our sixth decile. So counting from left to right, 1, 2, 3, 4, 5, 6. So therefore your D sub 6 or sixth decile is 8. Let's proceed with solving 84th percentile. So first, let us solve first the position of your P84, which is equal to 84 over 100. Why 84? Because we are looking for the 84th percentile, and it's 100 here because this is percentile, and we know that percentile divides the data or the given data set into 100 equal parts. Times 9 plus 1 equals to 8.4. It means that the 84th percentile is located between 8th and 9th element, which are 12 and 15 respectively. Therefore, our 84th percentile is equal to 12 plus 0.4 times the difference of the 8th and 9th element. So 15 minus 12 times 0.4 is equal to 1.2. So 12 plus 1.2 is equal to 13.2. So this is our 84th percentile.